Sudoku degenerates, welcome. This is a regular puzzle stream. I need a brief break from 6 out of 5 star difficulty Nabdanabans. So today I'll be tackling some easier puzzles and some snackdokus as well. I still got 2 or 3, maybe 2.5 more puzzle streams before the 21st to bring up the solve counts on some of the other pack puzzles. In the meantime, we're going to look at Supernova by Blobs. It's another galaxy puzzle. Okay, looks pretty similar to Volts from the Heavens. Oh, interesting. Okay. Normal Sudoku rules apply, so every row, column, and 3x3 box, I gotta put the digits 1 to 9 once each. I divide the grid into galaxies, orthogonally connect... Oh, hey, Andrew Sarkis. I divide the grid into galaxies, that's... I should probably turn on dashed grid for this. Orthogonally connected groups of cells that have 180-degree rotational symmetry around their centers, marked with a small dot. So, that gets me a few freebies right off the bat. But, more on that in just a sec. Gray dots mark Renbon galaxies, those with 2 or more cells whose digits form an unbroken consecutive sequence in any order. White dots mark galaxies whose digits do not form a sequence. Digits cannot repeat within a galaxy. As per galactic map standards, all galaxies with at least 2 cells indicate their smallest digit with a diamond icon. And all galaxies with at least 6 cells indicate their largest digit with a circle icon. So there are exactly 6 galaxies that are 6 cells or larger. There is one single cell galaxy, the supernova, that is not marked. Its location must be deduced by the solver. That throws a wrench in the works. Yes. Hence the title. Draw 8 straight lines radiating out from the supernova to the edge of the grid. Starting from the supernova and traveling outwards, digits along each line strictly decrease. You can think of the lines as thermometers with their bulbs at the edge of the grid and their tips all in the supernova cell. Okay, and there are... Now, the rules do not say that single-cell galaxies that aren't the supernova, that there aren't any single-cell galaxies that aren't the supernova, but those will be marked with a dot at their center. So the only real places they could be, obviously this is at least 2 cells, so it can't be. So there's only 2 spots for a single-cell galaxy that isn't the supernova. I guess I could I guess the last paragraph of the rule strongly implies that the supernova isn't at the edge of the grid, but I don't want to use that. Okay, let's just get started with, okay, these, there must be a border here. These have to be part of separate galaxies, and in fact, anytime you have two of the same shape next to each other, there's a border there. Oh, I should choose a color that stands out better on the wall borders. There. Obviously this boundary reflects rotationally, and here as well. Okay, but this... I think this has to be exactly 3 cells, because, otherwise it's, it wouldn't have a diamond, and since this is the center, it has to extend that way, but now these borders reflect out here. Okay, now this border reflects across this cell center. Oh, this is part of this galaxy, so this can't be. So this is just a 2-cell galaxy. Okay, this is a Renbon where the smaller digit is here. Oh, there's a freebie here. Oh, hey, Carl! Oh, and this is gonna rotate around there. Okay. Oh. Yeah, 2-cell on the edge is forced. Now, does the last paragraph of the rules actually imply that the supernova can't be on the edge? Like, am I meant to just assume that as part of the rules, or am I supposed to... oh, this reflects around here. Oh, this is part of this, so a galaxy can't have 2 circles in it, so that has to reflect there. Now, the supernova complicates all sorts of reachability arguments, but shapes I can still, like... which galaxy does this... It can only be part of this. So I know there's no border here. So there is a border here. So there's a border here. Okay. Now this has to join a galaxy. Oh, this galaxy's forced. Oh. This circle... There's only 2 galaxies that wouldn't reflect it off the edge of the grid, aside from this one, which it already can't be. But if it reaches here, it has to do so through here, and that forces this to be part of it, which it can't be. So I think this does have to be here. Okay, so I know that... Oh, this is reflected there. Okay, so that's this galaxy done. Okay, and grays are Renbons. So this is a 6-cell Renbon with the lowest digit here and the highest digit here. Oh. Where does this galaxy get its diamond? This galaxy is part of this. So it has to... this, it could go in either of these. Okay. Let's see. What? Oh. That's freebie, and this can't be part of this. So what is it part of? Oh, if it reaches here, it either goes through here or it reflects down here. Yeah, there's no way. Yeah, and those are the only ones it can reach. Oh, aside from this, but that reflects all the way down here. That's never gonna work. Okay, so this is in fact part of this. Oh, interesting. The only circle that this can reach is this, but that reflects off the grid, so this cannot be 6 cells. Now, the only diamond it can reach without being more than 6 cells is here. But it can't take both of these. And if it takes this one, it has to also take this one, because nothing else can. So there is a border here. Now, what does this reach? Oh, this could be the supernova. So I do have to be careful. Oh, does that also apply? Yeah, this could be the supernova, in which case... Or does something else break in that case? Yeah, this... Alright. Oh, but this reflects here, which reflects here, and this needs at least 2 more cells, so it does take those. Oh, and this reflects over here. Now this can't take this, so where does it get its diamond? Okay, that's more... Okay. Okay, that doesn't mean this isn't the supernova, but it does, it's more useful. Okay, now this one's done. This could be the supernova, so I can't make any connectivity arguments there. This does reflect here and also reflects a border up here. Now, this... I'm going to, oh, well, no. I'm going to... use cool colors for non-Renbans. And warm colors for Renbans. Oh, this has to reach this. Okay. Oh, if this takes this, then that's a galaxy. That would make this the supernova. But if this takes this, well, then I guess that could be the supernova, but then this galaxy would be absolutely massive. Oh! I think this cell is always the supernova? Because if it reaches here, it reflects up here. That doesn't work. Yeah, this... oh my god, this cell's always the supernova. Neat. I will use... okay, gotta remember the thermo lines here. Oh, that'll be... okay, but now I know this goes here. Okay, and now I can start making connectivity arguments, because this has to reach a galaxy. Oh, it could... no, because if it goes here, it reflects down here. If it goes here, it reflects here. Those are the only options. Oh, and also this, these both have to reach here, so that forces this. This is forced. Let me adjust my mic again. Oh, it's fully charged. Okay, I can finally unplug the cord. The cord is the biggest issue because it powers up, because I keep forgetting to charge it beforehand. This can't join this because it reflects there, and the only other option is here. Okay, so that actually forces this. Now this has to join this. Oh. This is resolved. So is this. Oh, and that forces this. Okay, galaxies are done. Okay, what's the longest? This is at least 7. Oh, and in fact, the only digit, this is a low digit, so the only digit in this box that can be higher than this is here. So one of these is 9, this is 8 or 9, this is not 9, which means this is not 4, because this is a Renban. Maybe I should just use a different color for the Renban galaxies. Oh, there's only 4. I'll color them pink. And I just gotta remember everything else. Oh, I gotta make this a separate color. Okay. This has to be lowest, this has to be high, and the range they cover has to be at least 7 digits. Wait. So these must differ by at least 6. So this cannot be 6.
We must be near the island.
Okay, Streamlabs through an audio error. Can people still hear me?
I'll get you there.
There. Oh, hey, Juggler. Got 2 entries from you in the queue today, actually. Yeah, that snackdoku pack you posted looked, extra tempting today. Oh, hey, Ambrose. This can be anything 3 or higher. Oh wait, this can't be 1. Wait, what did I... Oh. 4 or 5, okay. I guess, oh yes, in the 6-cell non... Oh, this is 8 cells. So this has to be 1, this has to be 9. This is also 8 cells, and it's non-Renban. Am I good? Okay. Am I missing any other obvious... Oh, where does 1 go in this column, then? Okay, that's not a 1, so that is not a 6. this can't be higher than this, so the max this can be is 5. Oh, this has to be 1, 2, because it has to be less than that. Oh, and this can't be 6, because I need a high digit here. Oh, where does 1 go in this box? Am I missing? Oh yeah, this can't be a 1 because that's the lowest. Okay, so that's a 1. Oh. Yeah, that's a 1 because none of these can be a 1 because this is the lowest digit here. Okay, what about, yeah. Same here. Either of these could still be a 1. But this resolves it. Okay, that's all the 1s done. Again, this can be anything other than 2. Oh, this can't be 8. This. A little over pencil marked here, but no 9 in row 4, column 1. Oh yeah, no, oh, in any of these. Yeah, there's no 9 in any of these. So 9 in this column. Oh, it could still go here. There's only 2. There are only 2 places for 9 in this column, though. Because this is a Ren bond, so it does need... Oh yeah, the 5 in here kind of looks like a 9 without with the diamond edge. No, 9 in this box is only here. So there's 3 places for 9 in this row. box. Oh. 9 in column 4. Of course. Of course. Yes, that... Ah, 9 in this column. No, it does. It gives us the 9 in this column. Let's see. Oh, and in this box... Yeah, I can't go here because this is a Renbon, and this is 7, 8, 9, so that is 9. Ah, and in this box now, this is the only place for a 9. Oh, so now in this box, the only place for a 9 is here. Which means that in this box it goes here. And, oh, that's powerful. You sold yourself short, Ambrose. That did do a lot. Alright, what about... There's always a 5 up here. This can't be 2 or 3. It can be anything else, though. And then there... oh. Obviously, 8 goes in one of these. Here. Oh, but it can't go here, because that breaks this. Oh, so no 8 here means no 7 here, no 6 here, and no 5 here. Oh, yeah, 2 breaks this. Nice. No, you do, you get the rules, yeah. Okay, so this is... maybe I should think about 2 and 3 in this column. Oh no, 3 at least could go here. What about 2? 2 in this column can only go in this galaxy, and since this can't be a 1, it must therefore be a 2. Three is less restrictive, but progress is progress. 2 in this box goes here. If this is 8, where is 8 in row 8? Oh! Neat. more generally, where is 8 in row 8? It can only ever go in here. Okay, but now there's no 8 in this box. 8 in this column. 8 in this column can only go here. There's only 3, 4, 5, 6. Because this is... Oh, I think this is only 2 or 3, because I know there's a 4 in here somewhere. And in fact, this can't be a 2 now, because it breaks this. So this is not 3, this is not 4. Fixes the low digit in the bottom Renbon. Oh, but there's no 2 in here. Only 2 spots for 2 in this column. Oh, yes. Oh god, it's a Renbon. This 7, yes. Okay. 2 spots for 2 in here. Either of them look plausible. Still, but... Okay, there's also a 2 up here somewhere. Oh. And if this can't be 1, it can only go here. That makes this a 2. Digits can't repeat in a galaxy, so that is 2. Because of the thermo. Oh, maybe I should think about 8 in this box. It can only go here. I think any of these can still be 8, though. Oh, yes, but the thermo forces it here. That is... Okay, 8 in this box goes down here, and there's no way it goes in the diamond in a 3-cell galaxy. There's 8 up here. There's 8 here. Let me good lift this. Just for completeness. Oh, this can't be 7. Because we've already got 7 in this row. Alright. Oh, yeah. Am I missing any... In this box, it goes here. Little X-wing on 2s here. Max, this can be a 6. There is? Oh! Yeah. So that's 3. Oh, that gets a ton of stuff. Chocolate teapot triple, but that's fine. So 5 in this row can only go here. So there's always going to be a 5 and 6 here. So this isn't 6, but it's also not 5. Only 2 spots for 6 in this box. Oh yeah, and this digit must go in this Renbon. Okay, so it goes there. Oh. That's 3. This is 7. 5 and 6. Is that resolved by anything? Not yet. Oh, but this is 7, which makes that 5. Aha, which at long last resolves this. Oh. And then there's 3, 4, and 7 left in this row. This isn't 4, this isn't 3. Oh, but there's no 3. I already have a 3 in this galaxy. Okay, so this is a 5, 6, 7. This isn't 5. So we got left in here is 3 and 8 resolved. Oh, this diamond resolves the 5 and 6. Oh yes. Ah, okay. So we got 3 digits. Oh, this is 5. We got a 6, 7, 8 triple. So this is 3. 4, 5 resolved. This is 6 or 7. 4, 6, 7, 8. Oh, what about... Oh, this column looks more interesting. 6, 7 pair here. Okay, this must be... Oh! Okay, so this is 7. That's 8, and that's 4. And now we just have 4 and 6. Neat. Oh, cool. Yeah, that was neat. Thank you for the GGs. Yeah, it was. I was surprised. I resolved the supernova, like, right in the middle of it. That was a really neat, bit of logic there. Yeah. Cool idea. Alright. Yeah, I like that. Okay. Now, Ichikara. I have not encountered Ichikara before, but it sounds very interesting. Divide the grid into regions. Okay, let's... Do I have an answer check? Edge must be in green color. Okay. Okay, so I divide the grid into regions. A region contains the numbers from 1 to n once each, where n is the largest number in the region. Regions may also contain empty cells. Okay, so I don't fill in any digits. I also know that things that are... That's a little easier to see. I'll just go over it with green at the very end. Obviously there's region borders here. Oh, you invented it after posting some, I did find out that basically the same thing had already been invented before, but there are only like 6 puzzles of it online, so it wasn't invented very hard. Okay, well that's some consolation. I, one time, accidentally invented a puzzle very similar to Shikaku. Only to find out... Okay. So, this is a new... Okay, so what I'm finding is that there's exactly 4 regions, right? Because the number of regions is equal to the number of ones in the grid. At least, if there's no question marks. There's no question marks here, so the number of regions is equal to the number of ones. So there's 4 regions. And there's 4 ones, 4 twos, and 4 threes. So I think these all have to be part of a region, right? Ichikara means from 1. Ah. Makes sense. One of the regions has to do this, right? Because, like, I can't trap anything on the region edge unless it's... Oh, no, it could theoretically go like this, or like this. Yeah, I gotta be careful not to make assumptions. Okay, well, this has to get out. Because it has to take a 2, a 3, and a 4. Oh. This also has to get out. I don't know that... Oh no, I do know that yellow and blue aren't the same, because what does... Because then this could never reach a 3. Okay, so these have to connect to each other and get up... Oh, and these now have to get up through here. Okay, maybe I should just use surface for now. Okay, that forces this to take this. And now this is... Okay, what do I know about how this... Well, let me, So, I'll color... Well, the puzzle is pretty symmetrical. Maybe I should, simply... Oh no, this does have to be... Okay, so this is forced to take this. Now, what about this? These are both forced to go up this way. Okay, so this takes this. This... Oh, this can go down here and take the 1. Wait, no. This still has to take a 1. Okay, wait. But this is now forced to go out, so this is forced to go out. This has to keep going. So does this, so does this. Okay, and now this 1, it's either going to connect to this one or it goes here. Okay, that forces this. Okay, so this... Oh. Yeah, there's no way for these to cross, so they... so that's the regions. Oh. It wants to be in green for the, solution check, but... Okay. First puzzle down. Okay, so now we're getting into question marks, which is... Mine isn't either. I eventually had to give up doing an answer check on the 4-color Yagelaminus just because no matter how I tried to tinker with it, the answer check just wouldn't go off. Thank you for the GGs. Oh, hi, Flinty! Okay, so now we get... question marks, which complicates our quest for... Okay, how many 6s are we getting? 1, 2, 3, 4, 5. I think we only have 4 given 1s, though. Okay, so there's 5 regions. I'm going to start by coloring each given digit a different color. Just to make it easier to count them and make sure I haven't missed any. Okay, 4 is yellow. So I got 5 6s. 4 of everything else. Okay. So, oh, and this has to okay. So, what we are looking at here is we have proven that these question marks they must contain a 5, a 1, a 2, a 3, a 4, and a 5. Because there's 5 6s. So these must be all the different digits. Oh, it's not gonna let... Okay. What about corner marking? Nope. Okay. Okay, I can get some... Okay, this takes this. So, suppose I make each of these a different color. Now I know that this goes here. Take a 1, 2, 3, 4, 5. This takes this. Okay, so that is the yellow 4. And of course, each of these question marks belongs to exactly one region. So one of these is... again. Curious what to look for here. Like, if this takes this, this has to get out through here. So what connectivity arguments? Oh, actually I don't know that all of these are part of different regions. It'd be tricky to have more than one in the same region, and I guess just by normal... I guess they can't all be part of the same region just because there wouldn't be enough other cells left over, because the max region size is 7. There's 4 7-cell regions and 1 6-cell region. Also 5 7s? Where's the 5th? Where's the... Oh, there are 5 7s. Okay. Okay, so yes, maybe we should... I was miscounting earlier. Okay, so... Obviously, this 7... You can't reach anything on the bottom row. For one thing, it can't... For one thing, the only thing it could even reach by taxi cab on the bottom row is this. And if it reaches this, that cuts off these. Okay, that's even easier to prove. So this must be green or blue. And if it's blue, it's going to cut off green. Okay. Yeah, I wish I could turn off ads entirely, but... Though honestly, if you have Firefox, ad block still works on YouTube, so... Okay, what about this 7? Which 6 does it link up to? Obviously, well, if it links up to anything except this, it's gonna cut off. Yeah, if it oh, it can't reach here by taxi cab. Because the max taxi cab it can reach is here. And if it links up here, it's gonna cut off these. Same if it links up here. So yeah, this is red. And now this... You can't have a region leave the border and then come back to it. Now can this... Oh, interesting. Now it could reach here by taxi cab, but it can't do it without... Oh, wait. With this being a 3, I think that works. Somewhat annoying, but that makes me suspect that's what it is, actually. So this would be 3. Oh, is that the only thing that works? It obviously can't reach here. Oh, and if it reaches here, it cuts off green. Yeah, no way can green take 7 cells. Okay, so this does reach here, which means it doesn't reach here. Okay, now. Okay, so red has to take this. And now red still needs a 3 and 5, and it can't reach any of the, yeah, that's actually forced. Interesting. If we have 2 question marks in the same region, we can never resolve which one of them is which, but that doesn't actually matter according to the rules. That's interesting. And in fact, I think this has to be green, right? Oh, in fact... Well, I know this... Yeah, because if it's not, green gets cut off. And in fact, green has to get out through here. So, the only question is this blue or green? I guess we'll find out, because blue has to get out through here. Oh yeah, it's gonna take this, because purple can't reach that without cutting it off. Similarly, oh, that's all purple. Very curious how this gets resolved. Well, okay, I know each of them is a different digit, and this is a 3, so none of these can be 3. So this needs a 3, so this becomes blue. Oh, and now blue needs a 3. Which it can only get here. Oh, and that forces this. Okay. So the question marks were still useful. Okay. Nice. Why, thank you. Okay, so now we have question marks and empty cells. So, training wheels are officially off. Let me count. Okay. Five ones, 5 twos. Is that all the 3s? Okay. Ah, only 4 4s, I think. Three 5s, 3 6s, and 2 7s. Okay, so this takes, well, I can draw some... I can draw some edges right away. Obviously this does not join this, so it gets out through here. Doesn't collect this. Okay, and now I can't get another 2 or another 3. Okay, and now it needs a 6. Okay, so one region is just a gimme. Okay, one region is done. Oh, maybe it could be useful to just erase all the coloring in regions that I've done. Because I still have to count, like, this gets out through here. So I know this needs a 2, 3, 4, and 5. Oh, it could go out here and get the 5 up here with this being a 2. Oh, is that the only way it can reach? Because it has to reach one of these two. And the only way it... Is this the only way to do that without repeating a digit? Because it's gonna cut... Because if it takes too much up here... Oh no, it gets a 2 here. Because... Okay, if it... Oh, I might... Okay, but if it can get its 2 here, I might be missing something else. I thought I'd proven that it had to, but... Now I'm thinking I might have missed another option. This is probably just going to be a 3-cell region. Recount. Oh, that's kind of what I'm doing. Because I'm left with 4 1s, 4 2s, 4 3s, 3 4s, 2 5s, 3 6s. The other one must be a 5. Right, that forces it, doesn't it? Yeah. This has to take this, or this. But if it goes through here, it's gonna cut a, it can't reach this without going through here, which would mean it has 2 5s. Or going through here, which would either take another 1. Yeah, okay. Okay, so it's forced to go through here. And now, the only way this... It can't take another 3, so it has to go around the 3. And now it still needs a 2, but if it gets to this, then this region that it cuts off can't have a 1. So it does, in fact, go here. Okay, and this can only reach here, and that's... Okay, so we got a region here. Okay, so now we got... We've got 2 of everything else, right? Oh yeah, that is... Yeah, that was resolved the moment I... Yeah. Okay, Oh. Well, I see a way that this works. Now I just need to prove that this is the only way that it works. Oh yeah, the fact that this needs a 5. And it can't get to a 2 without... Oh, yeah, okay. Okay. Now I just redraw all those region borders in the green. Neat. Cool. Let me try this one in Sudoku Pad. Let's see. Okay. Certainly easier to do the number count. Four fours, 4 fives. Four sixes, 2 sevens, 1 8, and 1 9. Three question marks down here and 2 empty cells. Okay. That would be the most elegant way. Maybe I should worry about the threes. Is there a way to... Does this repeat? Oh. I find it very suspicious that this would be a valid regen. Oh, yeah, 9... Oh, and it needs to get down here anyway. Because it needs an 8 here or in one of these question marks. And in fact, it can't reach any of these question marks just by taxi cab distance. Or wait, did the... Oh, the presence of these empty cells might mess with that, though. Like something like that. Or maybe getting a 7 from one of these. Yeah, that's also... Oh, that might mess with something down here, though? Oh. That looks like it causes problems up here, but I can't see an elegant way of proving that it does. And also, this might be less restrictive. Alright, I don't think I meant to... Well, okay, I know that this... Oh, no, this... Are these the is this the only other line besides this that actually works? And if so, does this cause problems? Oh, this region might cause problems for... Okay, if this is the region, then either this, then each of these, then at least one of these ones can never reach a 4, even if it's a question mark. Yeah, okay, so that's not gonna work. And obviously this doesn't work because it repeats digits. Okay, I think... Oh, this doesn't work because then this can never reach a 4 without taking an extra 3. So... Okay, but is there any other layout here that actually works? Oh, this causes a uniqueness problem down here. Because which region is this part of? Oh, unless this needs to reach... this? But how could I ever force it to do that? Okay, I don't think I've proven this anyway, so this doesn't work. This doesn't work. Okay, so this must take an empty cell. And if it ever reaches this row, it can't get back up here in only... Oh, maybe if it uses all 11? I don't think... Is there a more elegant way, or am I missing something more obvious? Ooh. If I do incorporate these Could it somehow reach, I don't see any other way for this, for the region with a 9 in it, with the given 9 in it to work. But I also don't see a way that this wouldn't cause uniqueness problems. Oh, but wait. Maybe only one of these even needs to reach a 4? No, because... Oh, if this works... No, there is a way for this to work. I think. I'm just gonna bifurcate this, because doesn't it work for, like, this... Oh, wait, no. Wait, no, we run into the problem with this still needing a 4. Oh, no, wait, this, and then there's a question mark 4 over here. Okay. I think that's what it has to be, because the only other line I can see is going to cause major uniqueness problems. So, how do I prove that this has to be the line? Oh, if this goes down, it has to go down, otherwise it can't take this. So now it has to go right. So this has to go this way. Now I can't take this, so it has to go there. Can't take this, has to go there. Okay, so the only variable is there. Now if it's here, that cuts off this 5 from ever... Oh no, this 5 can reach a 4, can reach a 2-4 pair here, so that doesn't even cause uniqueness problems. So that doesn't even... Okay, here causes... Okay, I am clearly missing something here. Alright, let me just think about the 1s and 2s. Which are also complicated by the existence of these question marks here, but Can I at least force this to be to also... Well, clearly not, because I thought up a way for this to get its... Yeah, I can't... Huh. That is... but if there's a question mark 2, there must also be a question mark 1. Does that cause problems later on? Which other way? Oh. Oh, this way. If we go here, we need a question mark 2, which means we also need a question mark 1. If we go here, we need a question mark 2 and 4. So we definitely need a question mark 1 here. Oh, but then this question mark can never reach a 5. So it would have to be like this. With a question mark 2 here. This being a 1-5 pair, that seems to work. Oh, this... How could this ever reach a 1 without going through 2 2s or cutting off something else? Oh. Is there a simpler reason why this breaks? Oh, hey, Dorlair. Going good, just taking a bit of a break from the pack judging to, I needed a break from 5-star Nop Donovan, or Donoben. This one just bottlenecks the top right. Right, yeah, because there's not enough 3s to go around. Sure, what's the LMD code? I'll see if I have time. Yeah, this... It's a little tricky to see why, but... Okay, like 3 6s. Each of these 6s has to reach a 1. So this would have to go down here. So basically, each of these 6s has to reach a 5 and a 1 and a 3. That's too many question marks down here. Okay, okay. So this way does not work. Even if I do it this way. Yeah, okay. Maybe just the 6-digit LMD code, because my chat eats links. Okay, and that's very forcing, because now this... OJS, okay. Okay, this has to reach a 2, which it does there, and now it can't take anything else. Okay, that makes this a 2-4 pair. And now this has to be a 1. Because once I've got a question mark 2, I need a question mark 1. But wait, how does this... Oh. Oh. Wait, no, this doesn't work. Oh, yeah, top right probably is easier. Let's see. This... Okay, so... Okay, the only way it reaches this 4 without taking this 4 is by either cutting off this 4 from anything else. So it does take this 4. Oh. Okay, this was correct. I see how this works now. This is all one region. And these are 7, 8, and 9. Wow. That was a bit trickier than the others, but wow, that was really cool. Cool, yeah. I might try this, like, on my next non-pack stream, which probably won't be for, like, a week and a half, but we'll see. The equally cool antithesis to the question marks equaling. Oh, hey, nothing wrong with easy. I could use easy after 3 straight streams, all of which were at least 6 hours of of judging Napdanabans for the contest. All right. Move this before the. Yeah. All right. Okay. I gotta refill my water and maybe grab a snack, but when I come back, we'll try this, which I saw suggested, I forget where. Oh wow, this is a very early version of Penpa. Alright, bye Ambrose. Alright. Oh, it doesn't even have a timer, wow. Alright, I will be right back. Alright. So, place one or more of the digits 1 to 9 in each cell such that the number in the top left corner of some of the cells is the sum of the digits entered in that cell. Digits in a cell must be unique And some digits cannot be placed, and same digits cannot be placed in cells that touch each other, even diagonally. Okay. This is either 4 or it's 1, 3. Oh, and one of these must be a 4 and the other must be a 1, 3. Yeah. Chat doesn't, chat eats links, maybe just the, oh, Sudoku pad, okay. Cool. Okay. So this is either, so one of these is a 4 and the other is a 1 or 3. So I can't use 1, 3, or 4 for these 11s. So one of them has to be 5, 6, the other has to be 2, 9, right? And whereas one of these has to be a 3-8 pair, and one of them has to be a 4-7 pair, because I can't put 2, 5, 6, or 9 in any of these now. I guess I don't need dash grid for this since I'm not. Oh, this just has to be a 2. You can't make 2 digits add to 2. I want to turn off conflict checker for this. Yeah. Six, 7, 8, 9 triple here. One is 6, 9, nice. The other is 7, 8. Well, wait. How does this work then? Because it's... Oh, this could be... Right, I can use any number of digits. So it's not actually true that these have to be 3, 4, 7, 8. Because I can add a 1 to 2 digits to sum to 10 as well. Although, okay, what about here? 1, 3, 4. That also rules. That rules 1 out of here, or anything involving and 2, 3, 5. So this must be 2 digits. Oh, I assume there's some, like, chess king's move, like maybe something here will rule a 4 out of here, or a 1 or something. Oh, the rules are in the pinned link. Oh, right. It says in each cell, not in each cell with a sum. Okay, this is going to be interesting. And this can be more than 2 cells, so this could also disambiguate this simply by putting, like, by having this be 3 digits rather than 2. But what was I looking at before? Oh yeah, this. Because this can't be 1, and it can't be 2, 3, or 5. 2, 3, and 5. So I think the only option here is 2, 8, and I'm gonna green cells when they're done. So this isn't 2, 4. So this is... Oh, and it's also not 1, 2, 3. So it is 1, 5, or just a 6. But this could be 2, 4. So I can't keep going with that logic here. I know that no more than one of these can have a single 6 in it, but I don't know that's the only thing, but I don't know that either of them has to. So the fact that I can't use 2 or 8 in this 18 sum, I mean, the minimum... I could make this 5, 6, 7. Oh, I also can't use 1, 3, or 4. Oh, so this has to be 5, 6, 7. That's the only option. Now this can't have a 8 in it, but it also can't have a 2, 5, 6, or 7. It's 1, 3, 4. Oh, and these are done. Okay, so there's no 1, 3, 4, 5, 6, or 7. That only leaves 2, 8, and 9, and obviously an 8 is not going to work. That is 2, 9. Okay, I'm getting the hang of this. This is neat. I've never tried a partiti before. Or partishi? Or I'm not quite sure how it's pronounced, but it's neat. Okay. There's no 2, 5, 6, or 7. Oh, and it can't be a 1, 3, 4 combo. So I think this is just an 8. If it's 1, 3, 4, then this has no value. I just don't get invited to partitis very often. Relatable. Okay. Oh. Oh, this is just an 8 by, I guess I can use uniqueness to show that every cell with no sum has to have a single digit in it. Because otherwise you could never resolve them fully. Speaking of, yeah, this is 9. Okay, what now? Oh. 13 without 2 or 8. Is that... It's not terribly restrictive. Oh, I wonder how this would work with balanced. Oh, you could do interesting things with... Yeah, I might give that a try. At some point. Now, there's no rules about repeating in rows and columns, right? Well, I certainly hope there isn't, otherwise I've already broken it. But no, I think this, yeah, I can't... Huh. Maybe I can do more up here. So I know that these can't be 2, 5, 6, 9. So they could be a 3, 8 with a 4, 7. Is there any combination that works? Is there any other combination that works and doesn't break the other? Like, say if I make this 1, 3, 7. Well, if I make this 1, 3, 7, that breaks this, doesn't this? Because then I can't make this 3, 7, 4, or 4, 8, and I can't put a 1 in it. Oh, and any of these that has 3 cells must have a 1. Okay, okay. Because I can't have a 2 in them, so yes, one of these is 3, 8, and the other is 4, 7. These are from 1, 2, 5, 6, 9. Oh, this 9. Oh, this has been forced for a while. This is 2... Oh, no. It could be 2, 7, or it could be just a 9. Whichever one of these it is, it's going to rule some stuff out from here. Oh, what about this? This can't be 5-9 or this breaks. If it's 6-8, that's fine. But it could also be 3 digits. If it's 6-8, that makes this 2-9 and this 4-7. So this would have to be 1-5 in that case. Now, does something that makes me suspect that that's correct? Does something break if this is? Oh, okay. If this is 1, 2, 3, this is 6, and now this is broken. Or wait, is it? No, this could be 4, 5, 9. What if this is 2, 4, and this is 1, 5? 3, 6, 9. That's... Huh. Wonder what this is gonna be. Can I do something with these? Well, I know this must be at least 4 digits. Maybe I should break out a killer calculator for this. Because 13 in either 2 or 3 cells, well, maybe 13 would be. Okay, if it's 3 cells, it's 139 or 157. So it would always have a 1 in it, which would make this a 4. And this is 6. Now, what if it's 2 cells? 4, 9, or 6, 7. I think 1, 3, 4, 5 would also work. It would break this. And it can't have an 8 in it. That rules out quite a few things. So it's 139, 157, 49, or 67. Oh, cool. Can I get a nudge? If this is 4 cells, it has to be 1, 2, 3, 6. It can't be 1, 2, 4, 5 without breaking this. 3 cells, it's obviously not 1, 3, 8. What's the maximum a 2x2 can sum to? Oh. 45. Oh, okay. Yeah, this has everything but a 1. Ah. Oh, and where does the 2 go in this 2x2? It goes in here. So it's 239, 248, or 257. What's 13 plus 18 plus 12? 31, 43. Okay, so this is missing a 2. So this is a 156 pair. I did that math right. Yeah, this sums to 43. So it must be missing a 2. Okay. Now, what about... Oh, what about... These sum to 42. Huh. Alright. 37. Oh, wait. Oh, 20. I thought I'd broken something, but no. This is... Oh yeah, there's a 2 in here. So yeah, this is 145. So this is not 3 cells, and it's not 3, 5, or 1, 7. It's 2, 6, and that's done. Okay, now we're getting somewhere. This could be... there's still quite a few options for this. But... Oh. The max this can be is 6. Because these sum to 39. Okay, so this is 1, 3, 4, or 5. Oh wait, is this forced now? This has to be 2, 3, 9, right? Because it can't be 1, 4, 5? Yeah. Okay, so neither of these has a 9 in them. Oh, and in fact, I know what digits they have in them. One has a 4, 5, 6, the other has 7, 8. Only this can't have 4, 5, so this is 7, 8. This is 4, 5, 6. This is only from 139. This is not... Okay, this could be 134. Or... it could be any of the 2-digit combos other than 1 set. It could be 2, 6 or 3, 5. Okay, so that's... less... restrictive than Oh, but now that the 18... okay. Okay, if this is 3 cells, I'm using this this calculator here. If this is 3 cells, it's 3, 7, 8. Oh, and because I've ruled out 1, 2, 5, and 6 from here. Okay, so 3, 7, 8 is the only option. Okay. This can only be from 2, 4, and 9. And there's only one of those that works. 4, 9, which rules 4 out of here. And at long last resolves these. So this is not 1, this is 6, and this is 1, 5. This is really cool. Switcheroo series, what is that? This is only from 3, 4, 7. Okay. This does not have a 1, 5, 3, 7, 8. That only leaves 2, 9 here. This is also, I don't even need the calculator for this, right? Because this has to be 3, 7, 8, right? Because there's only 4 digits I can choose from. And 4, 7, 8 is exactly 1 too many. So yeah, that's 3, 7, 8, so that is 4. Oh neat, I might check those out sometime. Now, this 25, it has no 2 or 9. Does this... Oh. Well, if I maximize... It's 4, 6, 7, 8, right? Didn't even need the calculator for that one. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh! Oh dear. I think I've broken something because this... Oh, this could be 1, 3, 6, 7, 8. In fact, just by Sudoku, it has to be. Well, I say Sudoku, but because this can only be 4, 6. So yeah, this is 1, 3, 6, 7, 8. So that's 4. Oh, that is neat. You have a grid of n with the digits n plus 1 and no repeats in rows and columns. You have given but 2 givens. Oh, neat. Oh, this is 5. This is only from 4, 5. Oh, this is also 4 and 5. because anything that touches both of these can only be from 4 and 5. Okay, this 17 is now much more restricted. Well... Oh, what about here? This can't be 1, 2, 3, 4, 5, 6, 7, 8. Oh, this is 9. Okay, so this can't have a 9 in it. That means it has to be at least 3 digits. Oh, I found where I'd gone wrong. At least, well, could I, just let me know if I have broken anything. Oh, this can't be 1, 3, or 4. This is 5. I haven't looked over here for a while. Aha, this has to be 2, 7. Okay, this can't have a 5 or a 2 in it, so that's just a 6. That makes this 2, 9, and this 5, 6. Cool. Oh, this 5 makes this a 5. Okay, so no 5 or 7. Could still be 1, 3, 4. Leaving 2, 7, 8 down here. That makes me suspect that's what it is. Oh. Oh, but if it's 2, 6, that breaks this. Can't be 1, 7. 3, 5. Oh, it has to be 1, 3, 4. Okay, that's all these done. This is only from 3, 8, 9. Oh, and it can't be 3, 8. Okay, this is 8. Okay, and that's going to resolve these. Okay, this 1, 2, 3, 4. It doesn't see 5. See 6, 7, 8, 9. Okay, so that's 5. 1, 2, 3, 4, 5. That's 6. All right, nice. Oops. Okay, so there's no 6 or 9. Nice in here. So that's not 2 cells, it has to be 3. Oh, maybe I should just, it's not 2, 4, 6, 7, or 9, so it's 1, 3, 5, 8. Oh. That's just 1, 5, 8, making that a 9. Okay, and that resolves this. Okay, so no 4, 8. So it can't be 1, 4, 5, 8, 9. 2, 3, 6, 7. The only combo here that works is 2, 3, 7. Okay, so this can't be 1, 2, 3, 4, 5. I hope it's 6. Yeah, it's C789. Okay. Neat. 38, 33. Nice. Ah, the good old days, back when solution codes were solution codes. Actually, will it let you... no, you would have to type them out manually. Alright. Or actually, wait, is there a... I might make a feature request to spend to let the copy cells feature recognize pencil marks. Or at least center marks. Alright, but yeah. Yeah, there is always a bit of a lag when things work up. Alright. But yeah, that was really neat. Okay, now time for Dorlear's submission. I don't want to go super long today, so I might just do... I'll just do 2 more after this. Alright. Rules are on each puzzle. Okay. Normal 6x6 Sudoku rules apply, so every row, column, and box gotta put the digits 1 to 6 once each. Draw a 1-cell-wide loop of orthogonally connected cells. The loop can't touch itself even diagonally. The loop must pass through all gray circles. Oh, thanks. Okay, so these are on the loop. Box borders divide the loop into segments. Each segment acts like a thermometer with a circle acting as the bulb. I.e., on each segment, digits increase as you move from the bulb towards the other end of the segment, and always in the same direction around the loop. Either clockwise or anti-clockwise to be determined. Not all bulbs are necessarily given. The digit on a given bulb, a circle, indicates the length of its thermometer, must be at least 2, but the digit on a hidden bulb does not necessarily indicate the length of its thermometer. Okay, and the only other rule is that these are consecutive pairs, and not all are given. Well, there's no way... This has to get out through here. Because if the circle's the bulb, it must be the first digit on the thing. Similarly, this has to go here, this has to go here. And I think I see connectivity, because there's no way that this goes here, because then these would be... There's no way it enters a region more than once, especially not if the regions are this small. If it can't touch itself even diagonally. So, I think it has to... This is the first. I think it... And if it must be length, at least length 2, then this... I think this is forced, right? Oh, similarly, if it can't touch itself diagonally, that means I know that this is 3 and this is 3. And this is 2, so this cannot... Oh, no, it can go up if it then goes here. Okay. This is either 3 or 4. Oh, it can just barely be 4 if it goes like this and there's a 3 down here. Oh, no, it can't be 4 because that's the smallest digit on there. Okay. 4 cannot be the smallest digit on a 4-cell thermo in a 6x6 Sudoku. I should make note that none of these are on the loop. Same with these. And since it never touches itself, that's forced. Okay. Now this is a 4-cell thermo. Oh, and this can't be 2 or 3. This has to be 1. So either this is a 3 or this is a 2. Oh, and this can't be 3. This has to be higher than 3. So this is 3 just by Sudoku. Oh, interestingly, this is always 2 regardless of whether it's on the, Oh? Oh, this is the false end. Right. Wrong end. Wrong end. I was looking from the wrong direction. Okay. So this is 1 or 2, basically. I think this is always... Oh, this can only be 2 or 4, because it can't be 3, and it can't be higher than 4, because it still needs to... Okay, so this is 1 or 5. Oh, so this can't be 2, because then these both need to be 1. Okay, so this is 4, this is 5, and this has to be 6. Neat. Oh, this is 6. This is 5 or 6. Oh, and this can't be 4 or 5, so this is not loop. Oh, good point. Yeah, this could be 3. Oh, but I think this logic still works, right? Because this can't be 3 and this can't be high. Okay, yeah. So everything... Oops. I think I... Oh, yeah. But, no. I still remember the stuff I did after that. Yeah, this... This has to be 6, and this can't be... Yes, now this can't be higher than this, so this has to be. That forces this, so this has to go there. Okay. This is 2 or 4. Now 2 in this region can only go here. 1, 2 pair here. Oh, 6 in this box. This box can only go here. So this is 1, 2. for 6. I think this can be as high as 4. It's not a... Oh, interesting that this digit and this digit have to be the same, but I don't see anything, any way that's useful. Up here. Oh, it can't? If it's 4... Oh, then this is 5, this is 6, so this has to be 5 and this has to be 6, and that breaks that. Or is there a simpler reason why it can't be 4? This white dot can't have a 3 on it. Oh yeah. Yeah, that was we were on similar. Oh. Welcome! Thank you for the raid! Crab raid indeed! Hey, nothing wrong with that. This is a more, this is a less serious, stream than most anyway. I needed a breather from the, pack judging, so I just decided to do some easy puzzles and snackdokus. Now, interestingly, 6 being on here makes this 4. Oh, 6 being on here doesn't work. If this is 6, this can only be 4, and now this cannot be higher than 1 and lower than 4. Yeah, okay, so 6 in this box only goes here, making that 5. Oh, I should turn conflict checker back on. Okay, 1 4 pair here. Two in this box goes here. Oh yeah! JoJo has the Kingler avatar. This digit goes here. This can only be from 2, 4, 5. Two can't go on the dot. Oh yeah, that rules. Oh yeah, that breaks this. So the even digit on here must be 4. Oh, and it's not 3. Okay, so it's 4, 5. That's 1. Aha! Oh, that's the loop there. That's 4, that's 5, that's 4. Okay, next puzzle. Oh, I should grade that as well. All cells enclosed by the loop lie on a snake. The snake is 1 cell wide. Oh, interesting, a nested loop. Oh, I could have... Wait. Oh, God. Yes, that would have been much simpler. How long ago could I have... Oh god, it would have been so helpful back here, yes. Ah, well. All squares are on the snake. Okay, so the loop goes around here. The snake and the loop can't share cells. Okay. I'll use this for loop and this for snake. A digit in a square counts the number of snake cells or the number of non-snake cells in the box. Oh yeah, that's fair. Yes, that would be tricky. Okay, every one of 3 okay, so the loop is a modular line. Maybe I should use that for loop then. Okay. So this has to be 3, 6 on the modular line. I'll use different shades of gray for the modular values on the snake. Yeah, it is pretty impressive. So there's a 3, 6 up here with another middle gray. Or I'll use light gray and dark gray for the non-3s. Oh really? The only loop and snake that works. Wow. With this rule set. Wow. That is... Oh, well this has to be an end of the snake. Well, either this is pink or this is pink. If this is pink, this is an end of the snake. Oh, and the snake... This has to be an end of the snake, right? Because otherwise... it's there, and either the snake touches itself or the loop has a dead end, which it can't. No, yes, that is a problem. Okay, so this is loop, and by modularity it is this. Okay, so we got a virtual 1-4 pair or a virtual 2-5 pair in here, and now I do something else with... If the loop goes down here, goes like that, which encloses that. Now it could just close up that way, or it could... Oh wait, this doesn't work because the number of segments on the line isn't divisible by 3. That works. Okay. Yeah. Oh, the snake is a region sum line. Okay, this, I missed this rule. Okay, so, obviously this is not the only snake cell in this box then. This could be, yeah. If this is like this, then this is 6. This is 3. Oh, that breaks, oh, actually, no. Then these are both 3. 6. Oh, one of these is a 6. And if it's here... Yeah, because one of these is the snake. And if it's here... Yeah, that forces this to be... That's too many. Okay. Okay, so this is forced. So that's 6, and these are both 3. Now, technically, it's possible for this... Oh, wait, no. This can't go down. Oh, unless it goes this way? I think that's... But now this... So obviously isn't a 2. Oh, but this being a 2-4 pair or wouldn't work, because then that still leaves 16 is not divisible by 3. Okay, but what if it goes down there? Oh, that is divisible by 3. Oh. That certainly helps. But this cannot be 2 cells. So I think this has to be 3, right? And there's a 2 in here. Oh, that's a 2. So either this is 1 and this is 2, or this is a 1-2 pair. I don't actually know which yet. I'll use yellow for cells that are neither loop nor snake. Oh, 6 in row 1. Aha! Okay, there's a 5 in here somewhere. Oh, in fact, this is a 1-5 pair. Wait, this is 4 then. Oh, okay. So this is 1, 5, 5, 1. And that doesn't tell me which way this goes. But this is 1 or 4. This is a 2-5 pair. Oh, this is 4, this is 1. Okay, so 1 in this box is down here. Oh yeah, this can't be 6. If it's 6, that breaks this loop. And regardless of which way this goes, this is always on the loop, right? In fact, these are always on the loop, yeah. Okay. In fact, by taxi cab, this is 2 or 5. Ah! So this is 4. Okay. That simplifies it. Oh, and I think if this goes down further, we don't have enough, we have the wrong number of cells on the loop, right? Yeah, because if this goes down any further... Oh, well, not... it can't even do that. Yeah, okay. So, loop is drawn. Well, okay, the obvious is that is 5, and that's 1 or 4. Oh, that's 4, that's 1. Oh, that's 4, that's 2, that's 4. That is 6. That's 1 or 5. That's 2 or 5. No, it's not 2, so that's 5. That leaves 1 and 3. 2, 3, 6, 5. Nice. Thank you for the GGs. Okay, we're at the midway point. And thank you for the crabs as well. Oh, I forgot to say hi to people who are coming in. Hi, Elam Damasi, Cathadora, Damo, Finks, Jojo, Stu, and Drunk Chess. Okay. Oh, okay. So this one's a counting loop. So if there's a 5 on the loop, there's 5 5s on the loop. The loop must pass through the bulb of every thermometer. Okay. Well, I know it does that. Okay, so there must be... There must be at least 15 cells on the loop. Because it's not possible that these are just 1, 2, 3, 4, because then this could not be any of those, because it has to be higher than... Wait. No, these could both be 4. Oh, but then this would be 1, 2, 3. This would have no value. Yeah, okay. So there must be at least 15 on the loop. Okay. And of course, there's a maximum of 1, 1. That feels important. This digit in this box can only go here. Oh, right, it's not necessarily at least 15. Right. Could be as low as 12, actually. Probably not, but we'll see. Alright, so... do these... And I know that at most one of these can be a 1. Which means that at most one of these can be a 4. So at least 2 of these are... from 5, 6. Huh. Not... okay. Oh, really? Oh. Even if there's no pencil marks there? Oh. Neat. Oh, that's useful. These have to be different. So do these. So these can't both be 1 and they can't both be 3. But I think they could be a 1-3 pair. Make this a 2-4 pair. Oh, this a 3-5 pair, which would force this to be the 1. Oh, yes, that is much simpler to spot. If this is 1, we have 2 1s in green. Oh, but if this is a 1-3 pair, then this is... But if this is 1 and this is 3... then this is a 3-5 pair, which makes that have no value. Okay. So, if this is 1, this is 2. And if this is 3, this is 2. But if this is 2, this can still be either 2 or 3. Okay. But if this is 3, this is 2. Oh, yeah. Then they're... okay. Close to... So if this is 1, this is 2. If this is 1, this is 1. Oh wait, if this is 3... that makes this 4. Oh, this is broken. Okay, so this is not 3. Okay, so we got a 4-5 pair here. Oh yeah, and if this is a 5-6 pair, that breaks this box. That breaks this, specifically. So this is 4. Okay, so I know that these... and now if this is 2, that's too many 2s. Okay. No, 4 in this box. And then 6 in this box. One, 3. This is 2, 4. Oh, where does 5 go in this box? That makes this 6. This is a 1, 3 pair, and it's not 3, it is 1. So this is 3, 1. Oh. 3, 2. 6. Okay, now all the 6s are green. And no more 2s are green anywhere. So, I can start graying out some 2s. This is 2, 5, 1, 3. Okay. Okay, there's a 5. Do I know for certain? Wait, this has to connect to this. Okay, I'm pretty sure the loop can never reach any of these cells without touching itself. So this is the only 5 that isn't green. The only 5 that isn't green is in this box, so this 5 must be green. Okay. Now, there's a 6 up here. Oh, and this, okay. That can't be 6, because 6 is always green. And all 5s outside of this box are green. I have 2 gray 4s and 1 green 4, so all the other 4s need to be green too. And there's the last one. That's 1. Oh, 2, 5. Oh, I still don't know. Oh, wait. That's 3. I have 3 gray. Okay, that's it. Okay, so that's 5. Nice. Oh, really? What was the global method? Ah, okay. Okay. So, I need... Oh yeah, I remember the full-size version of this puzzle. Use exactly 6 digits from 1 to 9 to fill the grid, with each digit appearing once in every row, column, and region. Every region is a snake. So it's a 1-cell wide path of orthogonally connected cells that does not branch or touch itself orthogonally. Some of the regions are Dutch whisper snakes. Within a Dutch whisper snake, orthogonally adjacent digits must have a difference of at least 4. Different Dutch whisper snakes, which contain at least 1 diamond, and cells with diamonds are on the Dutch whisper snake. Okay. They cannot touch each other even diagonally. So these must be in the same whisper, but it can't reach over here without taking too many cells. Oh, right, the loop needs an even number of cells. Okay. Right, which works differently in... Okay, yes. I see. Oh, yeah, yeah. Fascinating, okay. A digit on a diamond gives the number of snake cells, including a cell that it sees in either its own row or its own column with region borders obstructing vision. A digit in a diamond may see cells in the other direction, but those cells are not counted towards the total. The number in the top left corner gives the sum of the digits that are seen in that. In either its own row or its own column. Okay, so this counts cells in either its own row or its own column. Which I guess only applies if it's at a corner. Okay, so these are orange. This is at least 4. And at most 6. Oh, well, okay, in this puzzle, nothing can see more than 6. This is 2, 3, or 4. Right, and these two must be in the same region, because otherwise they'd be 2 different regions that touch, but they can't reach over here without taking too many cells. And I don't think... Well, maybe there is a way... Oh, probably not if... Yeah, I don't think there's a way for... Oh, wait. Oh, yeah, it is possible that these are 3 different regions. with this being a 1-3 pair. Oh, this doesn't seem to... Oh, this does, though, I think. This is 3, 4, 5, 6. Oh, and it can't be 6, because there's no way it sees its entire cell in one row or one column. In fact, since it has to take this, there's no way it sees more than 4, right? In fact, isn't this... doesn't it have to turn here? Oh, no, it could... Oh, but wait, no. Because Dutch Whisper, if this is 3, this is high and this is low, and that's not going to sum to 20. Oh! Welcome! Did I spell that right? I think so. Alright, welcome in! Yeah, this has to turn here. Okay, that forces a region border here, and here for that matter. Now this sees at least one more down here. Now this could be 3, 8, 9. In fact, these must be from 7, 8, 9. Oh, but wait. 4, 8, 9. That's too high. Okay, so this is 3, 7, 8, 9. Okay, and this... there's a border here. I don't know if it goes here or keeps going this way. So this is not 3. Oh, but there's no way it sees 4 cells that add... yeah, this is just 2. And it sees an 8 somewhere here. So 4 of the digits are 2, 3, 8, and 9. And I can only have 2 more distinct digits that are not those. Now, obviously, these are non-snake cells. the easiest thing would be this. Oh, then these would have to be different or the end of a snake. Maybe. Okay, there's either a border here, here, or here. Oh, thank you for the follow, Kukurikuj. Let's see. Do I know something about this? I know it's not 3, 8, or 9. Oh, and 4, 5, 6 is not 2, 3, 8, or 9. So this must be... Oh. Wait, this has to be 2, doesn't it? Because this region can only take a max of 2 more cells. So this is either 2 or 3, and it can't be... Oh, it could be 1. I guess this can only be 1 or 2. Can't be 4. And if it's 1, of course, then... Oh, then it doesn't turn. But it could just end here. And take more stuff here. Oh, but this snake has to get out. That's gonna... I also got to put 8 and 9 in this row somewhere. This digit goes here or here in this column. And this digit, i.e. 2, goes in one of these. Is there a... There's... Oh, I don't think this can be the 8. Because it's gonna break something somewhere. It's not the most... Whether there's an elegant way to prove that is a different question, but I think Oh, and I think this can't be either. Because it's either going to create two dead ends here, that snake's not long enough, or if it doesn't connect this, it's going to leave these without enough room to go places. Oh. In fact, maybe even this doesn't work. Oh no, that works fine. Okay. I mean, it's a bit... It's really look-aheady to say that this can't work, but I'm not seeing anything else or anything that looks even remotely seeable, so... Oh. Well, this can't be 6. Wait, how can this even be? Because if it's 6, oh no, it could be 6. Wait, 20. You just have to add the 6, including a 6. Yeah, this is not 6. Obviously that's not gonna work here, but this... Well, this can't see that... These cannot be in the same region. But how can that possibly... Oh, like this? Is that the only thing that works? Obviously, if this is a horizontal... This is a horizontal clue we get. Yeah, and this can't be vertical, because that breaks this. Okay, I think... Okay, now... Basically, this can never... Okay, so this has to take this or this. That rules this out of the 8. No, I don't want to do that. There's a border here when this means down. Okay, I think the only way to fit all these in here is this. That would make this a 1. Wait. Oh no, they link up here in that case. Oh, this... This is either this or this. Okay, so this only takes 1 in this, so this is 5. So it is flanked by... basically, this is 1, and this is a 2-5 pair. Oh, this is 5, this is 2. Okay. These are from 1, 3, 5, 9. That's not 5. That is also not 5 or 9. That is not 1 or 3. That is 1 or 9. There's an 8 in here somewhere. Oh wait, if this is orange, that breaks this. Okay. This can't go this way or that cuts off this, so that, Oh, I still don't know which way around these two get divided. Okay. So this is 1, 9. These are from 2, 3, 8. This cannot be 2. Oh, this cannot be 8, but I already knew that because this can't be a 2, 3 pair anyway. Okay, so there's an 8 X-wing here. So if this is a region, then 8 in this row must go here, which would make this 9 and this 8. Then... Oh, and by law of leftovers, this digit must go up here. Oh, and it's a 2. That simplifies things. So this is a 1, 5 pair, and where does this digit go in this region? It only goes here. Oh. Okay, that's 2, that's 8. Oh, and that's 3, that's 8. Now, if this is a region, this is 5, this is 3, and this is 9. Whereas if this is a region, this is 5, this is 3, this is 9. Wait. Oh, this sees everything except 9. That is 5. Oh, 5 in this row can only go here anyway. Okay. So this is from... This is 3 or 8. And this is 3 or 9. Wait. Oh, this is 3. Oh, that's 9. Oh, and now I can't repeat in a region. Okay. 2, 3, and 8. That's 3. Oh, that's been resolved for a while now. That's 8, that's 2. And that's 8, and that is 1. Okay. Turn off dashed grid. Thanks for the GGs. The product of the digits in a cage is equal to the sum of the digits between the 1 and 6 in the row or column the cage is in. One cell cage works for the row and column at the same time, and the product is the digit itself. Okay, so basically this is saying the digits between the 1 and 6 in this column sum to this. Okay, so it must be a 2-digit sandwich sum in both cases. Does that... Oh, this has to be 5, right? No, but wait, how does this... Oh no, this is 6. Wait. Doesn't this have to be 1, 2, 3? Well, it needs a 1 in it. Oh, this is 1, this is 2, 4, right? Because the sandwich isn't the because the sum is not the product. Okay, so this is 3, this is 5? Yeah, okay. Okay. So there's going to be another 2, 4. Oh, it has to be here. Can't be up here. One, 2. Okay, this... The product is equal to the sum of... Obviously, 1 and 6 can't be next to each other in this. Oh. Well, I see one thing that works. This being a 3-5 pair, 6-2-1. Is that the only thing that works? Oh, well, this being 6 breaks. Because obviously 1 would have to be here, and you can't make 2 distinct digits multiply to 4. Unless one of them is a 4. Unless they are a 1-4 pair, and neither of these can be a 1 or a 4. What about here, though? Oh, if this is 6, this is 5, this is 1. And you also can't make 2 distinct digits multiply to 9, especially if you can't use a 9. Or at least if you can't use a 9, and especially if you can't use a 1 either. So I do think the 6 has to go in here. And that does force this to be the 1. Yeah, now I have to minimize everything. Or at least I have to minimize the cage total. Or wait. 3, 6... No, that's not high enough. Yeah. Oh. Maybe I should have looked at this first. Without a 3... I mean, this needs both a 1 and a 2, right? Yeah, 2, 3, 4 is way too big. Oh boy, chat was telling me to look at this earlier. Oh boy. Yeah, I should have... Yeah, because if this doesn't have both a 1 and a 2... The next thing it can have is 1, 4... Yeah, that's also way too big. Oh, really? Oh. Yeah, okay, so this needs a 1 and a 2. 2 must go here, 1 must go here. Oh. That's forced to be a 2. Oh, and 1, 2, 6 doesn't work. What about 1, 2, 5? Ooh, that could work if the 3 was down here, but I don't think it works if it isn't. Yeah. Yeah, this is, yeah, I think this has to be a 1-4 pair. Which makes this a 5-6. And now if this is the 6, yeah, there's no way to add it to enough, so it needs to be... Okay, and now this is forced. Two, 3, 4, 2, 4, and 6. Oh. Solution code 4, okay. Yeah, it was neat. I might push it up to 4 stars for difficulty, but yeah, it was really cool. Alright. Yeah, I did. Alright. Let me message Paul Fly. Oh, I've stopped. I don't enter ratings on stream anymore. I'll input the solution code after. Oh, I need to refill my water anyway. Alright, be right back. Okay, welcome back. Did anything happen in the past? Oh, with the ratings? Oh, not to me personally, thankfully, but there was some drama a while back. Okay. So, draw a loop through the grid that visits every circle. In black circles, the loop must make a sharp turn and travel straight through both adjacent cells. So, a sharp turn is that, and it must go straight here. In gray circles, the loop segments must make a shallow turn and travel straight through one adjacent cell and turn on the other. So that works, and that works. We don't know. It can make any turn. And in white circles, the loop must not make a turn, and it must turn on both adjacent cells. Okay, bye, Dorlier. Okay, but this... and the reason this caught my eye is... Oh, let me reset the timer. One reason this caught my eye is I always did find it a little... that Masu rules, the turning rules weren't symmetrical. Like, in normal Masu with square cells, black circles say you have to turn on that cell and go straight through both of the adjacent cells. But with white circles, you have to go straight through that cell, but then turn on at least one of the adjacent cells. And I'm like, that's not symmetrical. The rules should say you have to turn on both of them. And thankfully, and this seems like the best possible answer to my, to that complaint. So, props to that. Okay, so now I have to figure out how to... actually break into this. Oh. Well. A white circle on the edge. That is, okay. That works the same as in square Masu. And now, I know this goes... It can't go here, because it would have to go straight through here. Okay. Oh, and now it can't go here either. Oh, and it can't go straight through here. Oh, no, it's this that would have to go straight through. That's... Okay, so I know that this circle, it goes here and then either here or here, but it goes straight here. Okay, and it must turn in one of these. But it can't turn here. Right, because it can't go straight through this cell. Okay, so it needs to turn here. Now, these cannot link up, or that's going to be a short loop. Okay, and that breaks the... Okay, so this is forced. So now this can't make a sharp turn. It has to make a shallow turn. Oh, and it can't have gone straight through here. Okay. Now if it goes up here, it's trapped. There's no way for this to... Okay, that actually forces this. Okay, now this has to get out here. Now it could... Let me clean up these X's. The two white circles touching each other are restricted. Ooh, yes they are. We do? The loop... Oh, the loop visits every circle, it doesn't visit every cell. Or do you mean something else? Okay. No worries, no worries. Oh, welcome back, Isaiah. I mean, it's not that cursed. Honestly, so far it's been pretty smooth. These are very restricted. Alright, so these cannot... Oh, so the sharp turn, it has to do this. Okay, and now this is not... Okay, so this is forced. That doesn't actually resolve... Okay, so this... Oh, well, this has to turn anyway, so that doesn't... Yes. Well, it can't in regular Masio. In this it doesn't actually say, but I'm going to assume that Masio rules, that normal no crossing rules still apply. Okay, so... Oh, and I know that this either does this or this. Oh, if it does this, that forces this to avoid, oh no, wait, that would do that. That's fine. I think either of those still work. What about... Obviously this... Okay, so this always goes here. And this either goes here and turns, or here and turns. Oh, neat! But this... Okay, I think if this goes this way... Oh, then this is all trapped. That's a much simpler thing to spot. So this now has to get out here to avoid closing the loop early. Same with this. Oh, now this can't enter here. Yeah, Masius are fun, especially Hex Masiu, which this is the first one of those I've seen. Oh, I should set a combined Masio Hexero. I wonder what the loop should tell you about digits. White circle in the middle only has one option. Let's see, if it does this... Oh, yeah, that'll cut off at least one of these. So that's forced, and now this can only link up to that, and this can only go here. Oh, neat. Okay, now these cannot link up to each other, so this has to get out. Ooh, that's gonna be tricky for... I think this now... The only option for this is this way, because anything else breaks. That has a very unique... Oh, is that a uniqueness deduction? But I can see something else. These two can't meet until they link up this, because this is a closed line segment here. So this is going to... And if this goes across... Oh, and if this goes up, that strands this for the same reason. So this has to go here, and this cannot touch that, so it has to go there, and now this links up with this. And now I can't link up these with this directly, so the only other option here is... and now this must make a shallow turn here and go straight there. Oh, and now this... If this turns here, it'll have gone straight in both of these cells, so this actually has to go here. This... Oh, now this can only go up here. Okay, and that leaves this with only one option. Okay, oh. Well, I see something that works. Oh, okay. I don't see the proof that it's the only option, but yeah, because I know that. Okay, yeah. Let me prove it. Let me prove it. Oh, here. Okay, that's forced, and that has to get out through here. Oh, okay, yeah. Now it's easier to see why that is forced, because if it takes this, right? Okay, yeah. Yeah, okay. Okay, yeah, that was neat. I like that a lot. I think, yes, I gotta make a whole series of Hexero. Like this. Well, maybe not a whole series, just a few. I will be merciful. But yeah, that was really neat. All right, let's finish up with this little 4x4 pack, and then we'll see who's on to raid. White chocolate raspberry creams are consecutive with at least one neighboring digit. Oh, that I think that would be this one. Okay, so it's got... The aesthetics here are amazing, by the way. Okay, so this is consecutive with at least one of these. Salted dark caramel chocolate truffles are not consecutive with any neighboring digit. Oh, and the sum of all these is an even number. Okay. Well, for this to not be consecutive with any neighboring digit, these can only be from 1, 4. And the corresponding 2, 3 is here. Oh, and this... Okay, so these are the same. Which means these are the same, because otherwise, like, if this is a 2, 3 pair, this is consecutive with at least... Or wait, no. No, these are different. Gah. Okay. This has to be... I had that exactly backwards. This digit goes here. Okay, which means this is not the same as this, so this... Okay, yellow in this column only goes here, so that's blue. So blue in this box is here. That is yellow. These are red-green pairs. But if this is red, it is not consecutive with either of these, so this is green. Oh hey, it's anti-night. Oh no, it's anti-night for 2 of the digits. For yellow and blue. Not for red and green, though. Did you know one thing I discovered in my little snackdoku setting thing the other day is that anti-king 4x4 is impossible? I did not know that until I tried to set one. Thankfully I didn't. Thankfully it broke early enough that I didn't really try to set. That I didn't wind up trying very hard, so it wasn't a crushing disappointment. Okay, these sum to 5, these sum to 5. Okay, well, this is just, okay, simpler. This is all 4 digits, so that's 10. So this is 2. To make an even number. 3, this is 1, and 4. More chocolates. Yes, please. I like chocolate. Okay, same rules here. Okay, where do I want to start the coloring? Well, let me see. Okay. These are the same digit. Now, and these are the same digit. Okay, but I don't actually know. Okay, maybe... Suppose this is blue. Or can I do more with the raspberry? I mean, if this is red, it automatically works. But what if this is blue and this is red? Okay, maybe if I start the coloring up here. Well, that's even less... Oh. Well, I know green and yellow are consecutive. Maybe that's... Well, I know this is 1, 4, this is 2, 3. Now, if this is the other of 1, 4... What if this is red? Then these are red, that works. What if this isn't red? Then this is 2 or 3. That's what I'm wondering. Does something break if it isn't? It's definitely consecutive with... Oh, wait. No, then it's not... Oh, then it's not consecutive with this. Duh, of course. Of course, okay. Jeez, okay. So this is 1, 4. 2, 3. So if this is red, this... Oh, no, wait. If this is blue, this has to be green, and this has to be yellow. Because blue is consecutive with green, but not with yellow or red. So if this is blue, this is green. Oh, is it worse than usual? Huh. I haven't... I mean, there's always some delay. It's hard to... It's sometimes hard to gauge whether it's, like, particularly... Alright, what does... So if this... Right, if this is blue, this is green, and this is yellow. Oh, and this is 1 or 4, and this is 2 or 3. So these are the same. Oh, this is simpler. Huh, that is weird. Oh, sometimes if you go into the video player settings on Twitch and then uncheck and then check again low latency mode, sometimes that skips ahead to when... Oh, maybe I have to use these to resolve this. Because, like, okay. If this is... Oh, wait, no. Because if this is blue, this is red, so this is blue, and this is green, then these are both green. Okay, so this is red, this is blue. This is red. Okay, so this is yellow. Okay. So 3 lots of this and 2 of this. So, 2 lots of this is always even regardless of whether it's 1 or 4, but 3 lots of this will be odd if this is odd. So, this is 2. Alright. Go on, just a few more chocolates. Oh, I am sorely tempted indeed. Alright. Same rules apply. Ooh, this is interesting. This configuration. Oh, it will? Huh. I didn't know that about changing the resolution. Okay, well this seems like the most obvious place to look. Because it makes these the same digit. Okay. Now, if there is... If this is red, this is yellow. Oh dear. Yeah, I've never watched Twitch on mobile, so I don't know the UI on there at all. So, what is this? If this is the other of 1, 4, this has to be its corresponding 2, 3. No, if this is... Oh, but then this... Oh, but then this would be red, and that works here. Okay, so that is valid. What if this is 2, 3? And that works here. Oh, then this would be red. Oh, so either way, this is always red. That's neat. I don't know if that was intended, but that is really cool. Okay, and these are always consecutive with each other, so I don't know... Oh, that was intended. Neat. Huh. It's amazing how powerful this... the raspberry dot can be. In the right circumstances, at least. If this is red, this is yellow. Ah, good point, yes. True. Yeah, this might have been... I might actually set a couple of these. I wonder how these would interact with the nightmare constraint. That is something I've been exploring lately. I have another nightmare snackdoku. I've been tinkering with. Did you draw these with Fill the Hats tool, or did you, I'm curious how you, like, rendered the graphics here. Let's see. Okay, these are always consecutive with each other, so this... just shapes in Unicode and lines. Oh yeah, Unicode for... the spiral, okay. Something to keep in mind. Yes, a good thing to think. Is this clue even useful? Because I don't think I've used it, and it's always going to be true by the Isn't this still, like, unique without this, raspberry cream? Because I don't think I used it to force this to be, red. I think I just looked at the top two boxes. Okay, there must be something. If this is red, this is yellow. Oh, but then the right. This cannot be a red-yellow pair. Okay, so this is red. Okay, that was way easier than I was making it. Okay, now let me get the rest of the grid. Wait. Oh no, this can be either. Okay. But I now know that. Right. So red and yellow cannot be in the same column here, right? Okay, that is, should have spotted that sooner. Alright, but, oh well. Yellow, green, blue, and green. Wait. Oh, I don't actually know whether, I know this is 1-4, but I don't know. Oh, but if this is 1-4, then this breaks. Okay. So green is 1-4, and blue is the other of 2 or 3. Okay, so now I can... Okay, that's 10. That is also 10. Okay, so yellow is 2. I think yellow was 2. I think whatever color I picked for yellow turned out to be 2 last time too. I can't remember. I mean, I think I already knew it was 2 or 3, so it's not that surprise. Okay, so red is 1, green is 4. I may have had too many chocolates. What is this too many chocolates of which you speak? I am unfamiliar with this concept. Alright, that was really fun. Gave me some cool ideas, and I would like to, that I should explore more of. In the meantime, though, I better stop there. Wow, a stream that lasts under 5 hours. That is also an unfamiliar concept. Thank you for the GGs. Alright. I didn't get through my full queue, but I need to take it easy on myself after the last couple streams, especially because still got 2.5 more judging streams to do before the Ooh, GX Aura is doing Root Trees Are Dead. Then there's... Oh, Blue Rail's doing Voices of the Void. That's another really cool game. Alright, I'll send you over to Blue Rail. Now I want chocolates. Thankfully, the snack that I got during my last break was a chocolate chip cookie, so... Alright. Yeah, I'll be back on Thursday with more judging. For Saturday with also more judging, though, that'll have to be a shorter stream because I'm on kind of a time crunch there, and then next Monday as well, and after that I should be back to normal stream. Oh, and after that, the current production is done, so my Wednesdays open up again, so I might be back to 4 days a week of streaming. Alright, I am gonna head out to make a Masu Hexero. I wonder what the loop behavior should be. We'll see. Alright. Okay. Thanks for joining me, and bye!